instance. Okay, I hope you can see what I'm sharing.
Yes.
Thank you.
Yeah.
So we want to continue. The first time we looked at how to, what was it? Divisibility. We looked at divisibility. We're implementing it in Rust, and then from there we came to prime factors. Now, prime numbers. We looked at how to get a code in Rust that can give us prime numbers between some range. So if, for instance, if you want prime numbers between 1 and 120, we have a code. We can come up with a code that will give us those prime numbers within that range. Now, so from there, we wanted to look at how to get the prime factors of a number. And I'm glad you did this last time. And we just want to go through the steps so that we understand how the code works. When you understand the steps, it becomes very easy for you to write any other code. Now, so here is the code. This is a general code. It can give you prime number. It can give you factors up to, if a number is in millions, like 20 million, 30 million, and so on. But a number greater than that, you may now require to have some algorithms that we look at, like the Pollard's row algorithm and other algorithms. So that is if the number is too big. But now this one that we have here, it will give us, if we have like 20 million, 30 million, 50 million, it can give us the prime factors. Now, so this is the beginning of the function. This is the beginning of the function. So you will say let the number be. So you define the number that you want to factor. And so then you then call the function. You then call the function that will do that. The function you'll be inserting, what you'll be inserting will be numbers. But then it will give you the prime factors. So we say print prime factors of the first number is here, and then the prime factors are in this bracket here. So you can see this is the number, and then we have the number, and then we have the factors. So what we input here is the number. What we input is the number, then the prime factors will then be printed inside this bracket. Now, so I had already explained this last time, mutable. This is mutable. So what this means is that the number you put, n, the n that you put, that is a number. It can be changed. It will be changing as time goes by. So that is what it means by mutable. So that number will be changing with the time. So for instance, if you input 8, then you input 8, at some point it become 4, then 2, then 1. That's what I mean by mutable. The number will be changing. So it's not static. That's what it means. Now, so you insert a number, which is mutable, and then it will change to a vector. Now the 64 here, we say these are bits, the bits. U here, the U here, when we say U64, we mean that the numbers that will be generated here, the numbers we are using are positive numbers. So we are dealing with the positive numbers. But if you want to deal with the negative numbers also, then you'll be using I64. If you want to generate also, if you want to deal with the negative numbers at the same time. But since we're only interested with the positive numbers, that we're using U64. So what U64 means, it means that we are printing numbers from 0 all the way up to 2 raised to 64, the answer -1. So this is what you mean by 64 bits. 64 bits. So these are approximately 4 million and something. I think 4 million or something. You can do that, just 2 raised to 64, then -1. What you get is what we mean by, so that means we can deal with the numbers from 0 to this number. That's what U64 means. If you say U32, then it means you're dealing with the numbers from 0 to 2 raised to 32. That is 32 bits. 32 bits, that's what it means when you talk of 32 bits, then -1. Now, when you say U raised to U8, then it means you are dealing with the numbers from 0 to 2 raised to 8 -1. But I said you can also use I64, but then now that it means they will have to share. For instance, if you say, supposing that we are doing with the UI, supposing it's I8. You see, if it was U8, we'd be dealing with the 0, the range of numbers we are handling will be 0 to this, to this is the range we'll be dealing with if it's U8. But now, if it's, supposing this is 255 something, let me see, what is that? 2 raised to 8, what is it? Then -1. The answer that you get, let's just do that so that we understand actually what we mean by bits. I understand we have people who are also new in computer science. So when we talk of 8 bits, it's 2 raised to 8. That's 256, and then -1. -1, that is 255. So it means when you talk of U8, it means you're only interested with the numbers from 0 to 255. This is the number you're interested with. So if this was to be, that means the only number you can, if you enter a number that is bigger than this, then this will not work. It will not work because there'll be overlap. Now, but if we talk of I8, we mean it's a half of this. Half of this, what is that? What is a half of that? Half of that is 127 there, 127. So it means we are dealing with the numbers from -127 all the way up to 0 included, all the way up to +127. That's what it means by I8. So it's good also to understand what these things mean as we use them so that we know what we actually are writing. There's a likelihood sometimes we may memorize something we do not know what it means. Now, so when we talk of I8, we understand what it means. So that means the range now reduces. The range reduces. So if U8 was from 0 to 255, we've seen that I8 will mean -127. That range all the way up to +127. So that means it can give you negative numbers, and it can also give you some positive numbers, but now the range reduces. The range of the positive numbers reduces. Now, so I'm just trying to explain what is happening here. Now, so, you understand the loops, the type of loops we have in Rust. We have the if loop and we have the while loop. I think there are three loops. There are three types of loops. Now, the while loop, we need to know how each loop is, how is used, what it means. We've entered a mutable number, a number that can change, a number that will be changing. And is not static. If you enter, like for instance, I entered 31,500, it will change from 3,500 to another number until I have the final. Number. Now, so we begin with this while loop. This is the outside loop, and then there's a loop inside. Now, the outside loop, what does it say here? It says n divided by 2. N divided by 2. So you check if the number is divisible by 2. That is, if it gives you a remainder of 0. If on division by 2 gives a remainder of 0, then it means that 2 is a factor. So that's why I've said if n is divisible by 2. Now, so that is a condition. That is a condition that you check first of all. Once you, or this, what we'll be checking will be the code. So the code, this code, once you input this number, it checks. That is the first condition it does. It checks. So this is a condition. Condition that must be fulfilled at this point. So the while loop here. So you know that the loop means that this thing will be happening repeatedly. To be happening repeatedly. That is what I think that's how I can explain the use of the word loop. It's not something that happens once, so it's something that is repeating itself. Now, so the condition, does this number on division by 2 get a remainder of 0? If that is correct, then you enter inside here. And inside here, you are told that if that is the reason, if that happens, if this condition is met, then push 2 to be a factor. You push 2 to be a factor. Now, so it means at this point, supposing this number is divisible by 2, we have obtained one factor. The one factor is 2. Now, what does n become? Now, this is what this one says. This one says the new n now is the original n divided by 2, or you can see this division. So this one means, what this means is that the new n is the only n divided by 2, or at this point. The new n becomes the only n divided by 2. Two together, that's what they mean. When you use this slash, you see this slash means division. And then there's this equals. So the new n becomes the only n divided by 2. That's when you combine these two, that's what they mean. So that means at this point, what is happening, I take my 1,500, so the new n now will be a half of that. After you get a half of that, let's just suppose that the half of that is 100. Let me just suppose the half of that is 100, although we know it's 17 something or 15. What then happens is that you again go to this loop and check. It goes back to this loop, the outer loop, and it checks whether this condition again is met. If the new n now is divisible by 2, if you find that the new n divided by 2, the remainder is 0, again, push 2 as a factor. So the other factor again is 2 at that point. And then what becomes of the new n? The new n now is the old n divided by 2. It becomes 50 and so on. So that is what this loop is saying. Now, so when you, after this step, until you, this loop continues. This loop continues until the number, the new n is not divisible by 2. Until the new n is not divisible. So when the new n is not divisible by 2, we proceed this other step. We proceed this other step. And this other step, we begin by checking now. We already checked 2. So we proceed to the next prime number, which is 3. And we call it I3. We let I be 3. Now, so the condition here is that the number that we're coming, the n we are coming with from above, this is the condition. It should be less than or equal to I times I. I times I, this is multiplication. So supposing we are coming with the 10, no, 10 is divisible by, so let's say it's coming with the 7. Let's say you're coming with the 7. So if you're coming with the 7, our I is 3. So 3 times 3 is not less than or equal to n. 3 times, because 3 times 3 is 9. So it means this condition has not been met. If this condition has not been met, you proceed to the next condition. But let's suppose that we are coming with 11. If you are coming with 11, you can see that 11 is greater than or equal to 3 times 3. So it fulfills, it comes here now. You can try it here now. It's tried here. You try it here, and then what does it say? When you find that I, which is 3, cannot divide this number. If it cannot divide this number, you increment I by 2. Is what it means. Is this condition here? It's plus equal to. So what that means, that the number you're obtaining, the number you're supposed to obtain, if I was 3, now the new I is 3 plus 2. So that is what it means by plus equal. Plus, so you increment by what is on the right-hand side. So what was on the left-hand side plus what was on the right-hand side. That's what it means. That's what this part means, that now we tried 3. After trying 3, add 2 to it. You try 5. After trying 5, add 2 to it. Try 7. So you try 7 continues until you find that it does not divide. If it fails to meet this condition, you proceed again, increment by 2. Now, so let me just take you through what I had written, examples. Or before that, I want to just run this, and so that we see that it runs. Okay, just before that. Okay, I'll take you through the steps. Let me just run this. You're able to see it, huh? Hello?
Yes, we can see your code.
Thank you. Okay, I added some notes, the ones I've just been explaining. Added those notes inside. Let's try the number that is just inside and see whether it's, of course, if it's a number that can be factored, let's see if it will factor. If it's huge than my program, then it will not. Oh, this one has factored. This one has factored, so it has given you. So you see what it did? It went through the first step, where the first step is a try if 2 is a factor. It discovered that 2 will not divide this number. So then it proceeds to the next step, this step here. Proceeds this step, because at this step, it discovered that just at the outside, while the loop, on dividing this number, we will not get a remainder of 0. So that means this condition is not met. So it proceeds this condition. Now, at this point, first of all, it checks if 3 times 3 is less than the number that is coming in. Discovers that 3 times 3 is 9. So it's less than that. And then it checks again. Here there are 2 loops. There's this while loop, and then there's the inside loop, while loop. So there are 2 loops here. Now it checks. It has already checked whether 3 times 3 is less than the number coming in. Now it goes to the inner loop and checks whether that number on division by I, which is 3, leaves a remainder of 0. In other words, if 3 can divide that number, it discovered that this condition was not met. So when this condition is not met, this inside condition is not met, what then happens is that it increments by 2, I plus 2. So the next I is 5. After I becoming 5, it goes back to the outer loop and checks if 5 times 5 is less than n. Discovered that 5 times 5 is less than n. It proceeds the inner loop and checks whether n can be divided by 5 and leave a remainder of 0. It discovered this condition is not met. So that process continues. So it adds again 2. Why is it adding 2? It's adding 2 to get rid of, because you see, when we tried 2 here, 2 took care of all the even numbers. So we want to get rid of the even numbers, because 3 plus 2 is 5. So you skip 4, which is an even number. It's not prime. You skip again, after getting 5, add 2, get 7. That means you skip 6, which is an even number, and so on. So that is what is happening. So the number that I was using for my working is that 1,500. Let's try that. That 1,500. Oh, that's a minute. I wrote something different instead of cargo run. Okay, so this one, you can see how the loop was done. The first time it went, picked 2, then it went again, the loop, second 2. Then after that, the number was not divisible by 2 again. It proceeded this step, here, where now 3 comes in, and then another 3, then increment by 2, 5, 5, then again 5 until we reach 7. Now, when you reach 7, you increment again. When you reach 7, you see when the n is 7, you increment again. When you increment 7 plus 2, that would be 9. So again, 9 is not this time 9 will not, okay, but it's an odd number. You can try it, but it's not prime. But it's, this condition just says I plus 2, where I begins with 3. So you're just incrementing by 2, by 2, by 2. So, but if you reach if you reach 3, 9 will not be there, because 3 will have taken care of that already. 3 will have taken care of that. Okay, so let me now share the notes so that we go through the steps. So yeah, what I was doing here was now breaking the code into bits so that I explain, but I've already done that. I already said this is the function. It begins by saying let. So you need to know what each of these means. I've said in Rust, this fn is the main function, and it's that's the entry point. That's where you're beginning, you are inputting your numbers and so on. So you have this let number. This declares the variable, and the variable here we shall call it number. So the variable is here is called the number, which is then assigned a value. That's why we say let number equal to that 1,500. So we're just assigning this variable the number. So the let here is just a word that declares a variable. A word, it's a keyword declaring a variable. So that's why you say let. Now we have this part that it says let factors be prime underscore factors in brackets numbers. So this one is just calling on the function. It's calling on the function that will be giving us the results of in terms of so that function is called prime factors. The function is called prime factors, and it will be giving us numbers. So again, we can see the use of the word let just to define the new variable. So the variable earlier was the numbers. Now the other variable are the factors. Now then we have this that assigns the result of the function. And that result, we shall call it the factors. So this is where it is. This. So these factors, and even this, they're used here. Now we have the print, and then the first bracket is for the number, and this other bracket is for the factors. Then from there, I'd already explained this. I'd already explained what mute means. And you see the n here, it means you're only putting one number at a time. So that's what it means. You're putting only one number. So mute n equals to U64. So this indicates that the parameter you're putting, the n, is of this type, 64-bit. 64-bit. And mute indicates that this parameter is mutable. And mutable means that it will be changing with the time. And so I said, then the number you input will come out as a vector. You input an integer, but it comes out as a vector. And that vector again is 64-bit. Is 64-bit. I explained the use of U, and I said sometimes you can use I, but then he said what I means. Now, what is the meaning of the word unassigned? I've used the word unassigned. I've used the word unassigned when I was referring to U64. Where is that word? It's here. Unassigned integers. When you talk of unassigned integers, just meaning that these integers are positive. They are positive. But when we say signed integers, then this will be negative. The signed integers will include both negative and positive. So an assigned integer is a form of integer in computer science and programming that only represents non-negative. That means these are positive integers. But when you talk of signed, then we would mean that the integers will be both negative or positive. And so when you want to deal with positive and negative integers, then you'll be using I64, for instance, or I32. That means 32 bits, but this one is taking care of both negative and positive integers. You can talk of I8, and that means 8 bits, but again, it's taking care of both positive and negative integers. But use 8 are only dealing with the positive integers. Okay, so I've explained what those means, 8 bits. 8 bits, I said 8-bit means 2 raised to 8 minus 1, which is about 255. So when you talk of U8, then it means the numbers are ranging from 0 to 255, because 8-bit is this. Now, 16-bit is 2 raised to 16. The answer you get minus 1, which is about 65, 535. So when you talk of U16, it means you are dealing with the numbers in this range. That's what it means. So you can see what U64 is. U64, we are dealing with the numbers from this to this range. This range, within this range. That's what I mean by U64. U32 is not very big because we are dealing with only 4 million, about approximately 4 million integers. So I32, this is the range. So you see, I said you just divide what was there and then apportion some part for the negative and the other part for the positives. Now there's this part that says let mute factors, and again mute we said is mutable. That means the numbers will be changing from time to that. So vectors, these vectors again will be changing. That's what it means. So this defines mutable variables called factors. So let we know what it means. Mute indicates that the factors will be mutable. That means they can change. After the initial vector, we shall get another vector that is different, and so on. We already know what U64 means. Now, this part I had already explained. While I had already said that while this is a loop, and I said you'll check and see different types of loops. We have the if loop, and know when that one is used, and we have this while loop. And so what that means is that the number is coming in. You check if that number is divisible by 2. If 2 can divide that number, and then you get a remainder of 0. If that happens, then you push 2 to be a factor. Then the new number becomes, the new n now becomes the old n divided by 2. This means that. So the new n becomes the only n. This is a divide. So when you have divide and equals combined, and you have divide and equals combined, it means then the new number we are dealing with is the old one divided by 2, or it's n, the current n divided by 2. Now, so I've said this loop determines if n is divisible by 2, and that this is what n divided by 2. And if n is if 2 divides n, if n is divisible by 2, then you enter inside and you meet this push factors dot push 2. It means add 2 to the factors. Let 2 be a factor. Add it to the factors. This part I've said, I've already explained what it means. Let me just show you by an example. I'm taking the example that I've just had. We've had that 1,500. We've input this number. Now we go to where you have this first condition, where you have this, while n divided by 2 equals to 0, then we want to see how this part will be working. We want to see how this part of the code will be working. So what happens that you come this while part and see whether this part is fulfilled, whether this condition is fulfilled. Check our n, if n is divisible by 2. That is, if n divided by 2 will give you a remainder of 0. If that is true, the program will say true. And then once it finds that that is true, then it pushes 2 to be a factor. So the factors we now have one factor. And then the new n, our n is immutable. So that means the new n now becomes the old n divided by 2, which means our n is now 15,750. Now, once this is okay, if we go back again to the while loop and check this condition. So that is our second iteration. Check this condition again. Does n divide this? No, does 2 divide this? If 2 divides it, the program says that is true. Then again, push that 2 to be a factor. So now we have 2 factors. We have 2 and we have 2. Update n. You know that is a loop. So it's going through the same process until we find that the loop is not accepting. So update our n. So our new n now becomes the old n, which was now 15,750 divided by 2, which is now that. So now our new n is now 7875. That's why we say it's immutable. Now we go through the same while loop. We check if this number is divisible by 2. When you check that condition and you find that it's not divisible by 2, so the program will say that is false. So the number is not divisible by 2. So if not divisible by 2, it means we are done with this loop. We are done with this loop, so we exit it and move to the next step. But we are moving with what are we moving with? We are moving from this part with the 2 factors and our new n. Our new n, this is now what is moving down. We are moving down with the 2 factors and our new n. Now, what is the next step? The next step is where we have let mute I be 3. Mute, that means this I will be changing also, mutable. The I will be changing. Now, so the first condition, once you reach here, the condition is check if I times I is less than or equal to n. So in this case, we shall check if 3 times 3 is less than or equal to, the number we are coming with. The number was 78, 75. So we check. If it's true, then we shall proceed. So that's why I said mute I. So you say this declares a mutable variable I and then initializes it to 3. That's the first I. It makes it 3. There is a let. So let there will just be introducing the I, the variable is introducing the new variable we're calling I. So that mutable variable, the let is just to introduce the new variable, which we shall call I. Now, after that, when it accepts this condition, when this condition is accepted, we enter the inner loop and check if the number is divisible by I. If it's divisible by I, you make that I a factor. What does the new n become? The new n is the only n divided by 2. Only n divided by I. Only n divided by I. That is what it means, divide, then equals. So it means the number we get, the number on the left is the older one divided by what is on the right. That's how that works. Let's just continue with our example. But there's something I've explained here. This part I've already explained. I've said while I times I is less than or equal to n, what it means is this loop checks whether the number that is coming in is less than or equal to, is greater than. So I times I should be less than or equal to that n. That's what this while condition is checking, this while loop. So what does that mean? What that means, I've explained it here. What I've explained is, we will not go through all the factors, trying all the factors. What we shall be trying, look at this. This is a square. This is a square. So we'll be evaluating, we'll be checking up to the square root of this number. That's what this means. Just checking up the square root. So if I is 3, and let me say that n is 16, we will not check up to check 11, check 15, no. We just check up to the square root of this number. The square root of this number is 4. So just check 3 only. Let me say this is 18. If this is 18, then we check 3. We cannot even check 5. We cannot check 5 because 5 is above the square root of this number. 5 is above the square root of that number. So you cannot check 5. So this program will not be checking all the numbers up to the number close to this. No, it just checks up to the square root of this number. So if the number is 25, it checks up to 5. It checks up to 5, the square root of this number. So it checks 3, then checks 5. If the number is 36, it will check up to the square root of this number. So you'll not find it checking 7 because 7 is above the square root of this number. So it will not check 7, it will not check 11, and so on. So that is what this point here means. And that is why there's this times here. This times is just trying to check if the square of that prime you want to check is less than the number. If it's less than the number, you proceed. You proceed and enter the inside loop. But if this is greater than the number, then you don't need to check. You don't need to check that. So you say the loop evaluates all possible factors up to the square root of n. If a number n has a factor greater than the square root, then that number will already have been taken care of. That number will already have been taken care of. Now we have the inside loop. The inside loop begins by checking if I divides n. Let me just show you how it looks like. This is what I mean by the inside loop. This is while, the inside while here. This is how it is. This is how that part is. So you have this is the inside loop. Checks if I can divide the n. That is what the inside loop does. And if I can divide n, it makes I a factor. And then it changes the n. The n is was mutable now becomes the all n divided by I. That's what the inside loop is doing. And then when we find that the outside loop cannot be accepted, cannot accept the n, if this part cannot accept, if this part is greater, if this part is not equal to, is not less than or equal to n, we come to this part, we come here, increment the I. If it was 3, now increment it by 2. This is what it means, plus equal to 2. So when we have plus, then equals combined, that means you are incrementing by the number on the right of the equal sign. You are adding 2 to the number on the left. So this is what I've been explaining. Now, so let's just see how that part will work. Our n is this, and we already have these two factors. So we then come to the outer loop. Outer loop says, check if I times I is less than or equal to this. If it's less than or equal to that, then the program will say true. Say it's true. It's true that I times I is less than or equal to that. So you enter the inside loop now and check whether the number is divisible by 3. If the number is divisible by 3, that means it's true that the number is divisible by 3, you make 3 a factor. So now we have 3 factors. We came with the 2, we now have 3 as another factor. The new n becomes the old n, this is our new n. So old n divided by what is on the right of the equal sign. Old n divided by what is on the right of the equal sign gives you, what was I doing here? This one was supposed to be, 78, 75, 78, 75, 78, 75. Divided by what is on the right, you get this. This is now a new n. We go back to this outer condition, outer loop again, and check whether 3 times 3 is still less than or equal to 26.5. So that one I checked it here. And when you find that it's true, you proceed here and check whether this number is divisible by 3. If the number is divisible by 3, push 3 to be a factor. So you have another factor there. And then our new n is the old n divided by what's on the right of the equal sign. That's what we mean by this, that condition, this sign. So our new n becomes this. Now check, go out the outer loop. The outer loop, you are checking if 3 times 3 is less than or equal to 875. You find that that is true. You find that that is true. Check if 3 can divide this number. If 3 cannot divide this number, it says false. So it's now time to proceed to increment. Proceed and increment. So our I now moves from 3 to 5. Now, once I moves from 3 to 5, you go to the outer loop. The outer loop, check if I times I is less than or equal. So this process continues. It's a loop. So it repeats itself. 5 times 5 is less than or equal to that. That is true. Does 5 divide this number? You find that again, that is true. So since that is true, 5 is made a factor. Our new n becomes the old n divided by 5. That's what it means by n divided by equals I. Our new n will be the old n divided by what is on the right of the equal sign. This time it's I is 5. Once you get this, you go back to this condition, check whether 5 times 5 is less than this. You find that is true. 5 times 5 is less than that. If that is true, now check if 5 can divide this number. That is again true. So 5 again, push it to be a factor. So again, we have another factor, 5. Our new n, all the n divided by. So you need to understand these signs as you write programs. What does this mean? What it means? So it means the new n now, the new n is just the old n divided by 5, what is on the right side. So it becomes 35. Now, check, again, you go to the outer loop and check if 5 times 5 is less than or equal to 35. You find that is true. If it's true, you proceed here. 35 times this, is it divisible? Yes. 35 is divisible by 5. So push 5 again to the factor. So you have another factor there. Now the new n is here. The old n divided by 5, which is 7. Again, check. Is okay. So in fact, if you were to go back to the outer loop, it would still have rejected. But I just came here straight. I said, is 7 divided by this. Also, when you enter the inside loop, I think you just remain the inside loop and then continue dividing. So 7 divided by this is not possible, so false. So if it's false, that is now time to increment I to be 7. So when you increment I to be 7, you come and check whether 7 times 7 is less than or equal to 7. And you find that this condition is not met. So it's false. You now exit that loop. What are you exiting with? You're exiting with the n, which is 7. You're also exiting with these factors. Now, so when you exit, what you now arrive at the last part of the code is this. This is the last part of the code. And what it says, if the number coming above is prime, or let me say, if the number coming above is greater than 0, no, greater than 2, then that number is a factor. Push it to be a factor. Because we've tried all factors from 2 to the square root of n. So far, we've tried that from 2 to the square root of n, and we found that we are left with a number which is greater than 2. So then it means that number must be a prime number. So that is the condition. That's a case here. That's a case here. Our n is now 7 and is greater than 2. So then it becomes a prime number. So you just push it to the prime number. So that is what happens here. Now, so this program that we've just looked at, this is a general program for finding prime factors, and so it can give you solutions to, let me say, if a number is 60,000 or even 90,000. But beyond that, what you need to do is you need to now use the algorithms we learned. And I'll just show you one algorithm that we learned, the Pollard's row algorithm, that will now be used to even factor large numbers. And sometimes it will take time for it to just factor the whole number. Let me just try and show you one. But we have so many algorithms that we can use. Some of them, they're not easy to implement on Windows, but they are very fast algorithms. Just a minute, I want to share. So what is that? You can see what I'm sharing, yeah? Yes? Can you see? Hello?
Yes, it is clear.
Okay, what are you saying?
Okay, from what I can see, okay, I can see your VS Code, then I can see also your terminal. From screen, from function main, line 1 up to line 31 of the last loop, while loop. Then the terminal is
Yeah.
also clear.
The first
Okay,
line
you have
is
CD.
use num. What are you saying? The first line?
The first line I'm seeing function main. Then the second line you have declared variable number to 31,500. Then up to the last line. Yeah.
That's an old one. Just try to close that. That's not the one I want to share. The one I want to share is the Pollard's row algorithm. Let me again try to share so that you can see. If you can tell me if it's that. Are you seeing something now?
Yeah, I can see your screen.
The first
From first line,
line, which
okay, first line, you have used some imports, use num bright, then
yes,
within bright,
yes,
yeah,
big
sure.
integer.
Big int, yeah, exactly.
Yes.
So,
Now, so this is the Pollard's row algorithm, and is efficient than the earlier one. It can factor huge numbers. My main function is here. My main function, I've just put it. I've put it here. This is my main function. This is where I input the number. And then so I think I tampered with it last time. Let me just see if it runs. Just a minute. It's not this one. Let me just share another one. Now we want to try and try to run a bigger number and see whether it can do that. Just open it first of all. It's not this one. Okay, there it is. Can you see it?
Yes, I can see it. From
Is it?
yeah, from your line 81 of the code. Okay, line, okay, from top. I, yeah, I think I can see you have imported some libraries. You
Yes,
use
yes.
num, brain something. Then from line 24, it's some. Okay, I think.
Good.
Okay.
Now, so you can see these are very many libraries, and these are meant to deal with the very big numbers, very big integers. And so when you come here, you can see the dependencies. These are the dependencies that you then include: num integer, num traits, and the big integer, and so on. Now, so the number that I've input is this. This is a very huge number. I think I had shared with Alex to share with you so that you can see if you can do it using the code you have just come up with. Let's try and see if it will give us the factors. So you can see says starting factorization, but these are very long numbers. So let's give it some time and see whether it will factor this. But the thing is, it's running. So it does not rejected, does not fail. So it's running. I think after some time, it's supposed to give us some integers, some factors. Let's just give it 1 or 2 minutes and see whether there'll be any results. If there'll be no result, then we can stop it. It means it will take time, but it's running. So you can see it's, are you seeing it's, it has written starting factorization for that number?
Yes, yes.
The problem we've done, we've not tested whether this number is composite or because we have not tested. It could be a prime number. So if it's a prime number, then we don't expect any prime factors. But if it's composite, then we expect that this program is supposed to factor that number. Now, this is the Pollard's rho. So let me just show you how it is so that you can try to write it and improve on it. You can see this is the definition. This is where the function is defined. Pollard's rho. This is n for the number. These are still just the definitions of those libraries. You can see here I'm using U32. Always change it. And again, here you can always change it. Now, the number of iterations, I've put the limit of 10 million. Those are the number of times it's supposed to do checking, the number of times it's supposed to check for prime numbers. So it's supposed to check 2, check 3, check 5, and so on. I've said, let's try to do 10,000 alterations. There's a loop here. Now, what that means is that there's a panic if we discover that if the iterations are exited, that is, if the number is huge, very huge, then so that it will be doing a lot of iterations more than this 10,000. If it happens that it has to do more than 10,000 iterations, then it just exits that loop. It means it panics. So that means it will not give you anything. That number is beyond. And that one should happen very fast. Very fast is supposed to tell that it cannot do this number. And then it panics and gives you the result that it cannot do that. But for a case, it has not panicked, so it's still working. Now, what have I written here? The main function here. I've said let the number be a string. This is string. Then n is a big number, and again, it's a string, just as I've already explained. But now it prints this. It prints starting factorization for this number. Now, if it gets the first factor, it's supposed to give us that factor, and then it proceeds and again proceeds. This is how it's proceeding, because this step gives us if there is a factor, and then again proceeds, and this other part again proceeds the other part. Now it will give us the period that it takes to do that factorization. It's supposed to give us that period. Then after that, it will print the factors, the prime factors of this number. The prime factors of this number, then it lists all those prime factors. It will also print as the duration, time taken. Now it appears this will take long. It appears it will take long. Okay, let's try and give it a slightly smaller number, because this one it will factorize, but it will take some time, and it's supposed to, and that is why we said it becomes very hard for you to crack, for instance, the RSA algorithm. Because RSA algorithm, we're expecting that the numbers used are even bigger than this number. And some of those numbers you can take even 300 years trying to factorize. If you, those two numbers, huge numbers are multiplied together. And then you're asked to factorize. Some of them, you can take even 500 years or 300 years factorizing. That means you may exit the universe before factorizing those numbers. But of course, we have faster computers and faster algorithms. But some of the numbers that have been used to make those keys, so most of the keys, nobody has ever broken those keys because of the difficulty of cracking, of factorizing these numbers once there are huge prime numbers put together. Like this number has very huge, there's some huge, very huge prime factors that are more than 20 million. One of them could be more than 20 million. So that one, if the number, you see, the steps we've said that this program is supposed to test all the numbers up to the square root of these numbers. Check all those prime factors up to the square root of this number. So that will take some time. It takes some time going through all those steps. Okay, let me stop this and then we give it a slightly smaller number and see what the result will be. I told you how to stop. I told the easiest way to be stopping this is just saying Control Shift, then escape. And then you choose Visual Code, then End Task. So let me again share it, and then we try it with the slightly smaller number and see what it gives us. But now, if you try it, what I want you to do, I want you to come up with this code, and then give it the number we've just given it, and then you leave it running and see how long it will take. Of course, it will tell you the duration that it took. Then you come and see if it will have run to give you the factor. Let's just give it a smaller number this time. That 500. Want to see if it's working. You can see what I'm sharing. Is that okay?
Yes.
Yes.
Okay, let's run. Submit. Just clean it first of all. Cargo clean. What does it say? What is it saying? Let's just see what the error is. Fail to remove file C. Fail to remove. Submit. Okay, let me again stop it. Again stop it and then share. Okay, let me now share it. Just a minute. Seems it's not running. Now, so let me just share this so that you just look at it, and then you'll try to see where the problem is. I'm trying to look at it. Because of time, I cannot see where the problem is. It was supposed to run. But let me just, because they are recording, let me just share it so you look at it. I want to try and run it so that you look at what it's giving us, what it's telling us, why it cannot run. We look at it later and you tell me why. Now, this is what I'm seeing. What are all these things? Saying, compiling this, linking error, linking with link X failed, exit code. I don't understand what this one means, this part. But then I'll try and I'll send this code later, and then you try to run it. I'll look at it until it runs, and then I'll share it so that you try it later and see why it's not running. But it's supposed to run. It's supposed to run. It's okay. Thank you.
Thank you, Dr. Sakwa. So tomorrow we pick up. I don't know if our students will be there tomorrow or they're going to protest, but anyway, we'll